Okay, good afternoon, class 10 students. Now we are going to forward our lesson. Everybody be ready. And I have already said you must have pen and paper. Okay? So, what am I going to do? I'm going to share the screen, and from the screen shared, I'm going to explain the chapter. But basically, what do? I will write the I will make you to write question and answer. Class 10. You know in which chapter are we nowadays? We are in chapter classification of elements. So what is given here? Now students, be ready. Write first question. First question is explain the position of hydrogen in modern periodic table. What is the question? Explain the position of hydrogen in modern periodic table. Okay, what should we say answer? Answer is hydrogen is kept in group 1A in modern periodic table. Hydrogen is kept in group 1A in modern periodic table because its electronic configuration is similar to alkali metals. Alkali metals. Its valence orbital or valence subshell is S. Valence subshell is S, which contains one electron like alkali metals. Students, do you know some examples of alkali metals? So lithium, sodium, beryllium, lithium, sodium and potassium, not beryllium. Lithium, sodium, potassium, they are alkali metals. Now next question. Define the representative elements. REPRE SENTATIB, representative elements. So those elements which lie in group 1A, 2A, 3A, 4A, 5A, 6A, 7A and 0. 1A to 7A and 0 are called representative elements. Their valence subshell is S and P. Okay, their valence subshell is S and P. Next question. How are metals, non-metals and metalloids grouped in modern periodic table? How are metals, non-metals and metalloids grouped in modern periodic table? So you can write here. Metals are kept in left side of the left ends at the center of modern periodic table. Left side and at the center of modern periodic table. Non-metals are placed on the right side of modern periodic table. Metalloids are kept between metals and non-metals. Metalloids are kept between metals and non-metals. So students, you keep in mind. So in modern periodic table there are 18 groups and 7 periods. And 18 groups means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 you can say, or group 1A2. 7A, and group 0. In that way also you can say. So what you have to remember, group 1A, 2A, 3A. Okay, remember 1A, 2A, 3A, 1B, 2B, 3B, 4B, 5B, 6B, 7B, and group 8. In these all groups, metals are kept. Okay, there are metals. Now, in the right side, group 6A, 7A, and in group 0, 6A, 7A, and 0, there are non-metals. And metalloids are kept between group 3A to 6A. Some they are found in 4A, some are found in 5A in zigzag way. So students, if somebody asks you to give the example of metals, then what is the example? What are the examples? Examples you can say zinc, gold, silver, iron, potassium. These are metals. Non-metals, you can give some examples of element gases like sodium, nitrogen, chlorine. Now the sodium is metal. Nitrogen, oxygen, chlorine, fluorine, bromine, these are non-metals. And metalloids, they are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. These are metalloids. So students, you keep in mind, near about 80% elements out of 118, 80% elements are metals. Then 15% are non-metals and 5% are metalloids. Okay. Students, now next question you write down. Define alkali metals. What is the question? Define alkali metals. So the metals whose oxides are soluble in water, the metals whose oxides are soluble in water and form strong base. Actually, strong bases are called alkalis. And from strong base are called alkali metals. They are kept in group 1A, IA of modern periodic table. Example, lithium, sodium, potassium, rubidium, cesium, francium, etc. Their valence shell contains only one electron. They are also called highly reactive metals. Highly reactive metals. Their reactivity increases while going from top to bottom. So now we are going to discuss group IIA or group 2. So here you have to write the question. Define alkaline earth metals. Define alkaline earth metals. So okay, the elements that belongs to group 2A are called alkaline earth metals. The elements which belong to group 2A, IIA, are called alkaline earth metals as they form basic hydroxides which are less soluble in water. They form basic hydroxides which are less soluble in water and they are found in earth crust. These elements are found in earth crust. One thing you have to keep in mind, elements which are kept in group 2a contain 2 electrons in their valence shell, and these elements are less reactive than alkali metals. Now, write next heading, define chalcogenes. Define chalcogenes. Give some examples. So, did you write the example of alkaline earth metals? You have to write beryllium, magnesium, calcium, strontium, barium, radium. These are examples of. So here, which one I have just circled? These are the examples of alkaline earth metals. Now chalcogenes, spelling, you just check it, CHALCOGN, chalcogenes. So what do you mean by chalcogenes? Chalcogenes are the elements which are found combined with copper in nature. Chalcogenes are the elements which are found combined with copper in nature. Group BIA elements are called chalcogenes because they are found combined with copper in nature. Example of chalcogenes are oxygen, sulfur. Remember, oxygen, sulfur. Others you can write selenium, tellurium, polonium. These are also the examples of chalcogenes. Okay, students. Now let's discuss next heading. What is it? That is halogens. HALOGENS. How do you define halogens? Halogens are the elements which form salts with group 1a elements. Halogens are the elements which form salts with group 1a elements. They contain 7 electrons in their valence shell. They contain 7 electrons in their valence shell. Example, fluorine, chlorine, bromine, iodine, etc. Okay, students. Now we are going to discuss inert gases. Inert gases or noble, NOBLE, inert gases or noble gases. Now what right there? The elements which are either in duplet state, the elements which are either in duplet state or octet state are called inert gas or noble gas. They do not take part in chemical reaction. They do not take part in chemical reaction, and the valency is 0. Valency is 0. Example, helium, neon, argon, krypton, etc. Now, actually students, what are we discussing, you know? We are discussing position of elements in modern periodic table. We discuss position of hydrogen, alkali metals, alkaline earth metals, chalcogens, halogens, and next one is inert gases. Now, transition elements. Transition elements. How to define transition elements? The elements that lie between group IIA and IIIA, means 2A and 3A, are called transition elements. The elements that lie between group IIA, 2A and 3A are called transition elements. They are also called D block elements. They are also called D block elements. Some examples are copper, zinc, and you can give example iron, silver, gold, etc. Now students, what are we going to discuss here? Define lanthanides and actinides. What is our next question? Define lanthanides and actinides. Here students, you have to keep in mind, lanthanides and actinides are group of elements. Lanthanides, one series of group of elements, and actinides are next series of group of elements. So the elements from atomic number 58 to 71, which lie after lanthanum. The elements from atomic number 58 to 71, which lie after lanthanum, LANTHANUM, are called lanthanides. So lanthanides means these elements lie after lanthanum. So there are 14 elements in lanthanides, and the elements from atomic number 90 to 103 that lie after actinium, are called actinides. ACTINIDES. Here are lanthanides, and here you can see actinides. So in lanthanides and actinides there are 14 elements. So students, remember, lanthanides and actinides are also called F block elements or inner transition elements or rare earth metals. Remember, lanthanides and actinides are also called F block elements, inner transition elements, or rare earth metals. Actually, why are they called inner transition? They are called inner transition elements because they lie inside the transition group. They lie inside the transition group. Okay. Now we are discussing next heading, reactivity of metals. Please write down the question. Explain the reactivity of metals. So what to write? The reactivity of metals increases on moving from top to bottom in a group of periodic table. What did I say? The reactivity of metals increases on moving from top to bottom in a group of the periodic table. Students, remember, these metals lie in which group? IA, IIA, IIIA, then IB, IIB, IIIB, IVB, VB, VIB, VIIB, and group 8. In all those groups, elements those elements which are kept over there are metals, and when we go from top to bottom, the atomic size increases. The bigger atom can lose the valence electron faster than smaller one. That's why when we go from left to right in periodic table, no, top to bottom in periodic table, in group, chemical reactivity increases. Here you have to remember, chemical reactivity increases means bigger atom can lose electron faster. Why bigger atom can lose electron faster? Because bigger atom has weaker nuclear force and smaller atom has stronger nuclear force. Students, now let me show you in the screen what is here. You can see lithium, sodium, and potassium. See the size of lithium atom, size of sodium atom, size of potassium atom. So what can we see? Lithium atom is the smallest, sodium is little bit bigger, and potassium is biggest. Can you say among these three elements which is the most reactive? Is it lithium, sodium, or potassium? See, for finding the chemical reactivity, we have to check the radius of these atoms. Which radius is longest? Potassium atom radius is longest. So, its nuclear force is weakest. Lithium's nuclear force is strongest. One arrow you can see going from top to bottom. It means chemical reactivity increases while increasing the size of atom. So here we can say potassium is more reactive than sodium. Sodium is more reactive than lithium. Smaller the atom, less reactive. Bigger the atom, more reactive. Because bigger atom can lose electron faster. I'm talking about metals, okay? I'm talking about metals. Okay, students. Write one question. Why is potassium more reactive than the sodium? Why is potassium more reactive than the sodium? Students, just before we discuss that, in case of metals, while going in from top to bottom in group, chemical reactivity increases. Means bigger atom of metal is more reactive, smaller atom is less reactive. So what do you think? Which atom is bigger? Sodium or potassium? Potassium. So potassium can lose electron from its valence shell faster. That's why it is more reactive. Now answer. Potassium is more reactive than sodium because both of them are alkali metals. Write on point wise, okay? Both of them are alkali metals. The atomic size of potassium is bigger than sodium atom. The atomic size of potassium is bigger than sodium atom. Potassium atom can lose valence electrons faster due to weaker nuclear force. Potassium atom can lose electrons faster due to weaker nuclear force. So, did you write in point or not? You have to keep in mind, okay? Now students, what are we going to discuss? Reactivity of non-metals. Reactivity of non-metals. So, question you can write. Explain the reactivity of non-metals. What can you write? The reactivity of non-metals decreases while going from top to bottom in a group of periodic table. Reactivity of nonmetals decreases while going or moving from top to bottom in a group in periodic table. When the atomic size increases, then the nuclear force or the force of attraction between the valence electron and nucleus decreases, and bigger atom of nonmetal cannot gain electron faster. Okay, cannot gain electron faster. So let me tell you students, if it is the case of metal, bigger atom is more reactive. If it is the case of non-metal, smaller atom is more reactive. Let's check in this screen what is given. Fluorine, chlorine and bromine. Fluorine, atomic size is smallest one. Chlorine, medium sized. Bromine, largest one. What do you think? Which one is most reactive among them? Is it fluorine, chlorine or bromine? It is fluorine. Fluorine is highly reactive, bromine is less reactive. Do you know why? Check the atomic radius. So, if you see the atomic radius, you can find out the atomic radius of fluorine is shortest, bromine is longest. My dear students, these elements, fluorine, chlorine, bromine, do they gain electron or lose electrons? They gain. Gain means smallest atom can gain electron faster because its force of attraction of nucleus is faster. Or faster means stronger. So fluorine is the most reactive non-metal among these three, and bromine is least reactive. Students, now we are going to discuss next chapter. What is that? Why is fluorine more reactive than chlorine? This question given. Listen. Fluorine, chlorine, are they metals or non-metals? They are non-metals and they are found in group 7A. So what can you say? What should be its answer? Fluorine is more reactive than chlorine because they are non-metals which lie in group 7A. Non-metals which lie in group 7A. The atomic size of chlorine is bigger than fluorine. Atomic size of chlorine is bigger than fluorine. Students, you can write in point A. Fluorine can gain electron faster in its valence shell than chlorine due to stronger nuclear force. So, okay students, today's class was like this. We discussed about position of elements in periodic table and the reactivity of metals and non-metals. You have to write again and again so that it will be settled in your mind. So in next class, we'll be discussing something new. So I will be sharing before the class in our messenger group. So practice and be ready. Have a good day. Thank you.